Okay, this video is just on some of the problems from the homework 8283. I'm going to do numbers 8 through 11. Again, since we only done section 8.2, you can really only do 1 through 12 right now anyway. And I thought 8 through 11 were some of the tougher ones. So we're going to start on some of these. First thing, I'm doing the inverse sine of the sine of 2 pi over 3. Now, my initial thought is inverse sine of the sine, like those would cancel each other out, and I'd just be left with 2 pi over 3. Not quite the way it works out, and here's why. If I'm doing an inverse sine problem, we talked about this in the notes, the answer has to be no bigger than pi over 2. Well, 2 pi over 3 is bigger than pi over 2, so there's no way that's actually the answer. So let's just go about it like we've done the other problems. First thing, again, I'm going to do just the sine of 2 pi over 3, and this is what we've been doing since November. So I go, okay, where is 2 pi over 3? Well, that's 4 over 6, so 1, 2, 3, 4 pi over 6. So it's a 60-degree reference triangle here. Then I go, okay, well, it's a sine problem, so I want to know the opposite. The opposite is the root 3 over 2. And then I got to ask myself, okay, is sine positive or negative in the second quadrant? All students, S. Sine is positive. So this answer is root 3 over 2. So now essentially what I'm doing is the inverse sine of root 3 over 2. And again, once I see inverse trig, inverse sine means immediately cross out the left two quadrants. So I'll cross out the left two. It's a positive number, so I'll also cross out the fourth quadrant because I need sine to be positive. Then I go, okay, well, what triangle is it that has root 3 over 2 for the sine? Well, it's another 60-degree reference, but notice that this time it's in the first quadrant. Again, here we had a 60-degree reference, but we're in the second quadrant. Now we have a 60-degree reference, but we're in the first quadrant. And the final question is, what is that angle? Well, that angle is pi over 3. And that was actually a pretty good pi on that one. So that's my answer to this problem. So again, you think maybe initially, let me get rid of this. You think maybe initially inverse sine of the sine of 2 pi over 3 would just get me right back to 2 pi over 3. It's actually the same triangle, 60-degree reference, but in a different quadrant. So you've got to be aware of that. Okay, so number 9. If I can get this to work. Come on. There we go. Okay, number 9, again, same kind of idea here. Inverse tan of the tan, you think they would cancel out, and I'd just be left with that. Negative 4 pi over 3. Negative 4 pi over 3, though, is way lower than negative pi over 2. So that can't be the answer because it doesn't lie within the range of what an inverse sine problem should be. So I'm going to do this like a normal problem. The tan of negative 4 pi over 3. Okay, so this is again what we've been doing for a while. Now don't let that negative really throw you off. This just means rotate clockwise. Yeah, that's clockwise. Negative 4 pi over 3. I know that's really 8 over 6. So I'm going to count 1, 6, 2, 6, 3, 4, 5, 6, 7, 8 over 6. So this is the rotation, negative 4 pi over 3. So what triangle is that? Well, that's a 60-degree reference. And then I go, okay, well, what actually is the tangent of this 60-degree angle? Well, this is root 3 over 2 for the opposite. This is 1/2 for the adjacent. And so opposite over adjacent would be root 3 over 2 divided by 1/2. That means multiplied by 2 over 1. And you're just left with root 3. Now, I got to be careful here. All students take calculus. Only sine is positive in this quadrant. I'm doing a tangent problem. So actually the answer is going to be negative root 3, just for this part that's in the brackets. So really what I'm doing now is an inverse tan of negative root 3. I go, okay, oh, inverse trig, here we go. Inverse tan means cut out the left two quadrants. So immediately cut those out. It's negative, so I cut out the first quadrant, and I've got to think, okay, what reference angle gives me root 3? Well, I've already done this. It's a 60-degree reference. I did it right over here, but it's just that I'm in a different quadrant now. So it's a 60-degree reference. And I say, okay, well, what is that angle? Well, that is, remember, for this inverse trig, I have to rotate backwards. That's negative pi over 3 is my answer there. Again, similar to this original stuff up here. It's just that I'm in a different quadrant, so the angle is actually different. Not negative 4 pi over 3. It's actually negative pi over 3. Different number. Okay, the next two are kind of bizarre ones. First thing I'm doing is an inverse tan problem, though. So, okay, immediately I go, all right, inverse tan. Inverse tan means cross out the left 2. This is a negative number, so I need to cross out the first quadrant. Now, again, I don't really know what the angle is. That gives me 3 over 4. I don't really care, though. All this is telling me is that there's some triangle down here in the fourth quadrant where the opposite of the angle over the adjacent is 4/3. So again, this angle, I don't care what you call it. You can call it happy face. That angle has an inverse tangent. Sorry, the inverse tangent of 3 over 4 is that angle. So again, the whole point of this is just figuring out where the triangle's drawn. So that's angle happy face. Now I'm just doing the cosine from that same spot, though. That same spot on the circle here. Well, if you do Pythagorean theorem, you get this to be 5. And now I'm doing a cosine problem. Cosine is adjacent over hypotenuse. 4 over 5. And the last thing, I got to mind my possible negatives. All students take calculus. Cosine is positive in the fourth quadrant, so this stays positive. Again, this seems bizarre. This is one I would consider checking in your calculator again, but it will work out. Okay, last one on these. First thing I'm doing is an inverse cosine problem. So I go, all right, it's an inverse cosine problem. Inverse cosine problems immediately cut out the bottom two quadrants. So immediately cut out the bottom two. It's positive, so cut out the second quadrant. I'm in the first quadrant. Again, this is one of those weird things. It's not like root 3 over 2 or something like that. But I know what this means is that there's some triangle, it doesn't really matter how you draw it, where the adjacent is root 3 and the hypotenuse is 13. So that's adjacent of root 3, hypotenuse of 13. Well, now I'm taking whatever that angle is. Again, I don't really care what it is. I'm just doing the sine on it. Well, sine is opposite over hypotenuse. All I have to do is figure out the opposite. This is, again, just a Pythagorean theorem problem. This one I'll actually work out, though. So it's root 3 squared plus x squared equals 13 squared. Okay, so root 3 squared is 3 plus x squared equals 169. Minus off the 3, and I get x squared equals 166. Not a very pretty number, but who cares? So my side length here is square root of 166. So again, let me recap. I was doing an inverse cosine problem, so I immediately cut out the bottom two quadrants. Since it was positive, I also cut out the second quadrant, because this is where cosine will be positive then. I know that the adjacent over hypotenuse had to be root 3 over 13. Well, on this exact same triangle, I wanted to then do the sine. Well, the sine is opposite over hypotenuse. So the sine is square root 166 over 13. And everybody's positive here, all. So the sine, which is what I'm doing in the end, is positive. And there we go. Sine is square root 166 over 13. Not a very elegant answer, but it is still the answer and it works just fine. Okay, hopefully this helps a little bit more on that homework.